Hello and welcome to today's Saratech enablement session. My name is Andrea Hall and I'm the Customer Relationship Manager at Saratech, and I'll be your host today. Presenting today, we are lucky enough to have Todd Perella from Siemens PLM. He has been on the NX team and he is going to talk about rethinking design with generative design and convergent modeling. Our sessions run about 30 minutes each, and they are all recorded and posted to our Saratech YouTube channel. Make sure you check out the past sessions there. Twice a month, we meet right here to learn about tips, tricks, new and old features that will help you with your everyday tasks. This is an open forum, so if you have any questions or comments during the presentation, please type them into the chat box and I'll kindly interrupt Todd and just let him know your comments and questions during the session. And with that, I am going to pass it over to Todd.
Hey, thanks, Andrea.
Sure. Let me just give you the screen here. There you go.
Okay, great. You see everything okay?
Yes.
Perfect. So good afternoon, everybody. Thank you for joining today's session. As Andrea mentioned, we're going to talk about generative design and how generative design can allow you provide ways to reimagine design, give you greater innovation and better business value for your company and your products. As Andrea mentioned, my name is Todd Perella. I do work in the NX product management organization. Myself and my team are responsible for driving the product capabilities and improvements in the NX software. One of my particular areas is over the last few years has been a focus on generative design, design for additive manufacturing, lightweight structures, convergent modeling, which is a Siemens invention and innovation that's really helps this process. So today I want to talk to you about that in order to take best advantage of generative design, it really requires that our customers have a change in mindset. But not only a change in mindset, they really need the support, and they need to be supported by that end-to-end digital software thread that we can provide them. So what's the opportunity for our customers to think in these new and different ways? If we can get our customers shifting from conventional ways of thinking to reimagining how they could redesign their products or reinvent their manufacturing processes, we believe there's great business value to that. And using things like a generative design thought process, using maybe an additive manufacturing way of thinking, all these things can provide great benefit from better products, improved performance, more innovative manufacturing production methods, reducing costs, reducing needs in tooling and reducing dependencies on supply chains. And so you really can take this thinking to multiple levels, and ultimately it helps your customers rethink the way that they do business. And our goal is to have them become more innovative, more productive. And I'd like to illustrate the benefits to rethinking by sharing a little story with you. And you're probably wondering what this is a fennel bulb, by the way. You're probably wondering what this has to do with generative design and rethinking your design processes. And I was also pretty intrigued when I saw this. It turns out that this fennel bulb was an inspiration behind a project that one of our Siemens sister divisions in the industry sector underwent. And it was the inspiration and sort of the challenge for them to change the way that they think about a problem to unlock the potential of that generative design, and in this case also additive manufacturing could bring to the business. So the goal of the project was to reimagine how they could redesign this high temperature burner system. This burner is used in a fuel refining process. It's a thermochemical conversion process that burns leftover messy reactants or fuel at extremely high temperatures to extract, additional usable fuel from that sludge, so to speak. The temperature in this combustion chamber is incredibly hot. It's over 1,300 degrees Celsius, which is in actuality higher than the melting temperature of the metals that this part is made from. And you just saw from that video the incredible cooling efficiency that this burner has with the fact that it could be under extreme heat and be touched by the human hand without burning or impacting that person. So it's an incredibly efficient design. But the conventional way that it was designed and manufactured has a lot of challenges and a lot of drawbacks. And the challenge was to figure out if there was a more elegant way that this burner tip could be redesigned that would reduce overall manufacturing effort, but do this while maintaining the functional performance, right? You can't lose any efficiencies in performance. If you look at the image, on the left-hand side of the image, you have the burner tip. And that is the area that burns the reactants. It works by having these networks of ring-shaped tubes that are all welded together that do a combination of transferring the sludge reactants as well as transferring cooling water to the system. On the right-hand side, you see we have a series of connected flanges that do supply all of the fluid into the burner tip to do the burning. And this is like I said, a series of connected pipes. They're welded together. There are many machine components, and there's a lot of constraints around the system by the way that it's made today. So the challenge was, again, how could we reduce this, get improvements in manufacturing of this product, but also could we do it at a cheaper cost? So the aha moment came from, here we go. So the aha moment to this whole challenge was when the engineers took a different approach. They used a generative design and an additive manufacturing way of thinking to try to help them inspire, get inspiration from possible new ways that they could design this burner tip. And one of the great benefits to additive manufacturing is the fact that it can empower engineers to think, to consider new shapes, new radical forms that really were never able to be manufactured using traditional methods. In fact, I tend to say that many of these radical ideas that people are thought of are not the constraints of the human mind, but more of some of the existing, manufacturing processes that we have available. And with additive manufacturing, there's a saying, however valid, that manufacturing complexity almost comes for free, which we'll talk about that a little more details, not exactly the case. But nevertheless, the engineers at Siemens and our Siemens division used a couple of different ways of thinking. They used the concept of biomimicry, which is looking toward nature to be inspired by what nature has done to solve problems, and then imagining how the combination of biomimicry and additive manufacturing might help them produce this part differently. And so the inspiration of this fennel bulb was that people looked at the engineers looked at the fennel bulb and they said, wow, this actually looks awfully similar to the current burner system that we have today with the complex network of connected tubes, all sort of coming together at the root of the bulb. And so, like many areas of design, inspiration can come in many forms, and this was just another great example. The really awesome thing from my perspective was that this model that you're seeing was entirely designed in NX. It is a complex parametric model of this new concept. And you can see here from the cross section that the interior is quite complex, with a complex network of cooling channels to prevent this whole burner from melting. So the engineers were able to achieve this form. It often looks like an unimaginable form in reality in some cases, by letting computing algorithms do much of the work. And this is where aspects of generative design comes into play. The way that that our Siemens division did this was they were able to take a digital twin of the model, that parametric model in NX, and they linked it into another Siemens product, Star CCM, for computational fluid dynamics. And then they took another solution from Siemens called HEEDS, which is I like to equate to the conductor of an orchestra, which basically allows you to run through all sorts of parameter configurations in a design to figure out, basically exploring the design space of possibilities to figure out what the best possible combination of parameter changes might be to achieve, your desired result. So the result of the design challenge and what they were able to achieve was a significantly more elegant design. Number one, they took all the complexity of that system and they were able to transfer it directly into the tip of the burner, the 3D printed tip, that is. So you see, they took complexity out of 90% of the rest of the system and put it localized and concentrated it into one spot. By doing this, they were able to significantly reduce manufacturing effort, where again, all the complexity was put into the 3D burner tip. They had a significant reduction in assembly complexity. They had a reduction in the number of parts, the number of welds. They were even able to reduce the size of the part. So it's a fantastic example of rethinking design using generative thought processes and additive manufacturing thought processes as well can really change the game for your customers. What are some of the limitations today to achieving this way, this new way of thinking at an industrial scale? And this is very typical that we see out there. And it all comes down to, from our perspective, it comes down to disconnected softwares. This world and working with these new methodologies is really, in some respects, bleeding edge, and people are sort of kludging together different pieces of technology to try to make things work, which then means you've got multiple file conversions. You have no control process, so you have a workflow that's not controlled. You have no real PLM environment to take over and control that workflow for you. And then, as I mentioned to you already, there's the aspects of, conventional thinking can often also get in the way. So what's Siemens doing about this? Our strategy around solving this problem for you is that our vision is that we have this one integrated industrial strength solution, from requirements driven generative design all the way through to production, in this case, 3D printing or using other manufacturing as well. And all of that is encompassed through our data and process management pipeline through Teamcenter. And I think, ultimately this is very much aligned with the Siemens value proposition as a whole, right? Our ability to bring a complete workflow solution to you in a single integrated platform and environment and way of working. And so if you take a look at the products, and you've heard me mention at least a couple of them already, Siemens can bring to you a strong portfolio of all of the elements that you need to be able to pull this together. And the value being that much, if not all, of these components are all sitting on the same software platform, which means you have levels of integration greater than you were ever able to achieve prior. So I'm going to go into the next few minutes talking a little bit more detail about each aspect of this, and hopefully give you a much better picture of how we can really help you bring all this together into one integrated end-to-end solution. And so I mentioned to you that simulation and performance simulation can drive, really can drive the design the optimization. So using simulation, we can really evaluate the performance of the system. We can capture the requirements all the way down to the component level. These requirements can be all sorts of things. It can be material selections. It could be different system loads and constraints. You can feed into the simulation the design space availability, what kind of cost targets you want to achieve, what have you. And then using that combination of NX with SimCenter, you have a seamless integrated way to capture these requirements and then reuse them in an associative manner. Those requirements that we capture through simulation and performance simulation are then fed into an accurate design optimization, where now what you have is the function of the product is driving the design. And then capabilities like topology optimization can be performed in a much more natural and intuitive way, in particular because we have this technology natively integrated in the NX design environment. So the designer can easily set up their design space, set up their loads and constraints. They can select their materials, including, and very importantly, including their ability to optimize against desired manufacturing processes. So I've mentioned to you, and you see the underpinnings of additive manufacturing in this presentation as one of the optimization constraints that you can apply, but it's not synonymous only with additive manufacturing. Topology optimization can be leveraged and be of great benefit regardless of the manufacturing process you wish to apply to it. For example, we can have the optimization be constrained to a molding and casting manufacturing process, or we can constrain it to a machining or extrusion process. So the fact that we can integrate not only geometric optimization of the optimum structural form, but the fact that we can also integrate manufacturing considerations into the optimization is critical to you and very valuable to you. One of the other benefits that in this case additive manufacturing can bring is the opportunity for further lightweighting through integration of lattice structures into the design. And oftentimes lattice structures can help realize improved lightweighting, and while at least maintaining performance, but oftentimes we've been finding that we can even improve performance through the integration of lattice structures. Structures themselves can be great tools to perform structural engineering on the part, additionally and beyond what topology optimization can do. And so by feeding information, our ability to feed information about the lattice structure itself into the optimization, it then becomes possible for the generative algorithm that's doing the optimization to use that information to recommend areas in the design that could benefit from that additional lightweighting. So you see how we have all these pieces of technology and how they can all be seamlessly put together to get greater benefits. And then from my perspective, as I mentioned to you before, the conductor of the orchestra, this really all comes together, and our customers, our customer, can realize the greatest benefit from generative design by taking a multidisciplinary approach to the problem, where all relevant load cases, all different material options and considerations, different mounting positions, different manufacturing positions can be considered in that optimization. And you're now allowing the computer to provide you feedback as to the best design options. It can then provide to you back that information where you can make an intelligent decision and down select on a solution that best meets different often competing design constraints. And that happens to be one of the biggest challenge in these multidisciplinary optimizations, is that the constraints on the system can often be competing with one another. So having a software solution that can help you determine that best option is invaluable. Again, because NX is a multidisciplinary design platform, it becomes easy to then feed the results of optimization back into simulation for further validation. So for further simulation, either considering many more load cases, and validating that the design actually continues to meet the different requirements on the system. So within SimCenter, passing the data directly within NX from CAD to simulation, you can evaluate those load cases. You can consider things beyond structural. So you can consider thermal, fluid motion, acoustics, durability, what have you. At any state in the process, a designer using the NX tools is able to easily refine the product form or even rework it using an extensive set of modeling capabilities. Tools such as Convergent modeling for working natively with the mesh geometry without conversion. The key thing is that NX is allowing us to now work with mesh geometry as any other geometry in a CAD system. Or even using NX Realized Shape, which is our subdivision modeling tools, which makes it so much easier to make changes to complex freeform shapes. Also, you can incorporate aspects of aesthetics. You can much more easily prepare your models for additive manufacturing or other manufacturing methods like preparing it for mold design or even other just generalized downstream uses. Having that core set of CAD modeling tools that NX provides, again, is critical to this. The fact that you can take mesh geometry and evolve it immediately without having to do extensive reverse engineering is critical. And the fact that we have the breadth of CAD tools with subdivision modeling, with synchronous modeling, and other to be able to make design changes easily in the design is a great benefit to you. And then finally, we have the aspects of tying from design and simulation and validation into manufacturing, using our manufacturing tools to prepare and process the designs for additive manufacturing. Here, you're looking at our ability to, with our integrated additive manufacturing build preparation tools, to prepare a job for printing. Not only that, we have the ability, because again, all of these tools are natively integrated, including our additive manufacturing tools being natively integrated with the rest of our manufacturing solutions. It becomes easy to take a part from additive manufacturing into traditional manufacturing for further processing, as well as even into closing that loop by tying into inspection programming. I'm sorry, let's skip forward. So Siemens Generative Design Solution enables that next generation of product design from design to production in a single platform. Our ability to use generative design processes, starting from the system requirements, using those requirements to explore the design space and optimize on that with a high degree of automation is invaluable. Critical to this is our ability to consider multidisciplinary requirements and our unique ability to get production-ready results with tools like Convergent modeling and NX Realized Shape. And then finally, as you've seen throughout here, is the fact that also in combination with this is that our additive manufacturing thought processes and capabilities combined with generative design can really offer even greater levels of efficiencies and innovation. So with that, I hope that you see that Siemens, we view ourselves as a leader in what we call the next generation of design, which is all about helping our customers reimagine design for better innovation, business value. With that, I want to say thank you for taking the time to listen to this thought leadership session, get a bit of a picture about what Siemens can bring to the table and how we believe we can really speed up and help you with greater innovation in your processes.
Awesome. Great job. Thank you so much, Todd. Even I understood a lot of that. So I really appreciate that.
Oh, good.
And yeah, it was a great presentation. And I would love to hear from some of our attendees that are online right now. If you already are using this kind of generative design and you have some feedback, we would love to hear from you. Some of you joined pretty late, and so maybe you weren't aware that if you have questions or comments, you can go ahead and type them into the questions or the chat box over to the right-hand side. We will keep it open for just a another minute or two while I'm going over these last few slides. So please feel free to type those in there. And we also have a quick survey right after the session ends, and we would love to hear from you. Let us know if you have any suggestions for future sessions, or if you have any questions that you would like Todd to follow up with you about, or the Saratech team. We'd be happy to do that as well. Our next session will be October 18th. Like I said, we meet right here the first and third Thursday of every month. And we are going to be talking about what's new in NX12, and we have presenters from Siemens once again, Tim Kelker and Taylor Anderson. So it's going to be kind of split into two parts, and it'll still be about a 30 to 45-minute session like always. Make sure that you register on the Saratech website, and if for some reason you can't attend, go ahead and register anyway. And that way we can go ahead and send the link out to you right after the session ends. We will still send the link to you. Let me see. We do have one question here, actually a couple. Andreas wants to know, is the output of generative design in STL format only?
Yeah, thank you for asking that question. So the output of generative design comes in the form of a mesh body, which you often think of as STL. So yes, that's accurate. And the value that we can bring to that inside of NX is that in NX with convergent modeling, we can take that and use it directly throughout the rest of the process. We can do modeling operations with it. We can add and remove features. We can use a combination of mesh modeling and traditional feature modeling on that geometry directly without conversion, without reverse engineering to move it through the rest of the process. Along with that, we also have a very robust and capable set of reverse engineering tools, which you may or may not be aware of, to essentially reconstruct and wrap surfaces around that geometry as needed. And we found that for a variety of reasons, using the mesh body directly through convergent modeling is incredibly powerful to work fast and quickly, but also people have the desire to want to reverse engineer the shape at a certain point in time so that they can get the benefits of the traditional parametric modeling and engineering design intent into the model. So summary, yes, it's a mesh body that can be exported as STL directly. We can work with it directly with Convergent, and we can reverse engineer it as needed.
Awesome. And I do have a few others. Let me just export this. So Mark Tellem had a couple of questions, I believe, here. So he said, hi, thank you so much. Is this NX12, and are you using Nastran and Team Center? He's wondering if how we're doing the integrated analysis.
Sure. Yes, we're using, it is NX12. So everything I talked to you about is in production software today. Nothing, new or future visionary there. And it's using, our whole suite of tools. So it's using NX. It's using our topology optimization for the designer tool for designer level topology optimization, and it's using NX Nastran for advanced simulation, the advanced simulation requirements. You also saw slides around that showcased our NX lattice structures design tools, which are part of NX CAD. So you did see a combination of tools, but yes, all NX SimCenter / NX Nastran.
Okay, and he also wanted to know, can we add parametric PMI features to the tessellated / mesh body?
So the answer is yes. The PMI tools do work with the mesh body. I will caveat that we do come up against this quite a bit. As the mesh body is essentially amorphous in shape, you can add PMI to it, yes, but what you can add to it in terms of some of the analytic information that you typically add into a classic CAD model is limited, meaning there's not necessarily a plane or a cylinder or something to call out a radius or a planar face on. But for a generalized application of PMI, PMI regions, notes, doing various level PMI dimensioning, yes, that is possible. But I don't want to oversell it there. There are limitations and constraints to working directly with the mesh today, as opposed to doing added reverse engineering.
Okay, awesome. And Andreas, Mark, I hope we were able to answer your questions. If there's anything you need further, please feel free to send us an email. You will be getting an email from Saratech with the link to this session, and that's a great way for you to be able to just reply if you have any questions, and we'll get back to you on that. So thanks for answering those. Let's see. And if you're ready to take it to the next level at Saratech, we also provide lots of other things other than just PLM products. We also have engineering services to address your demand for advanced engineering capabilities. We have lots of great experts right here on hand. If you have been a customer with us for a while, you've probably called our support line and talked to lots of our awesome engineers. And we also have a booming additive manufacturing department at the moment. We actually have a couple more different types of machines now than what's listed here. So make sure you check out our website at saratech.com. We are on the road at the moment. Some of our guys are in Texas on an additive manufacturing road show, and they're going around and just showing off some of our machines and talking about some of their capabilities. And so if you'd like to learn more about that, let us know. And make sure that you follow us on all of our social media, especially YouTube. Make sure you subscribe to our channel. We're posting these customer enablement sessions, but we also are posting lots of shorter videos to help you. I know a lot of times it's hard to sit around for 30 or 40 minutes and watch one of these videos, so we have very short videos to just show you some tips and tricks and different capabilities. So make sure you check out our YouTube channel. And with that, I hope to see you all here next Thursday again. We will be sending that link out today or tomorrow, and we just appreciate you taking the time out to be with us today. And thank you again, Todd.
You're welcome, Andrea. Thank you. It's my pleasure. I'll maybe do it again sometime.
I would love that. All right. Thanks. Have a great day.
You too. Bye-bye.